Hello friends, I am Shravana and welcome back to my channel Sparkling Future. Before starting with today's topic, I request all of you to subscribe to my channel and also please like, share, comment and hit the bell icon for the latest video notifications. Thank you. So in most of the interviews, first question they will ask like what is the difference between Hadoop and Spark, or what is the difference between Mapreduce and Spark. So today we will discuss about the differences between Hadoop and Spark. So actually it all started around 2000 year, where big companies like Google, Yahoo, Facebook, Twitter, such companies were storing lots of data, right? So for example, let's take Google. So whatever question we have, immediately we will do the Google search. So when you search up for some topic in Google, the Google internal engine should be able to give you the better search results within no time, right? You expect that search to give you exact result in the main page, and you don't wait for the page to come up. You need that very quickly. But for giving you such kind of results, right? So Google has to store it, or it has to have that search engine to get the required details for you, right? So and all this data cannot be stored in a one single server. Even Facebook, so earlier we were not using so much of social media, but uh, everyone started using the social media. Everyone has to started updating the details, photos, pictures, voice messages, everything. So here the main problem is the data is the main problem. So for and all this data cannot be stored in a single server. And similarly for all the other companies, right, like Google, Yahoo and all that, whoever uses these search engines and this social media, so for that they need to put more investment on the memory, like for the multiple computers for the memory. And they have to store lot of data, and also if someone is searching for something, they have to give the results immediately. So then for upcoming from this issue, for overcoming this issue, they started using the parallel processing, and then for using the other multiple machines. So they wanted to come out of that data issues. Okay, so that's when Hadoop came into picture. And Hadoop actually it came like open source and free, and it has distributed and resource manager kind of features, right? So that's when it became very popular. And Hadoop provided three layers. Okay, like that time earlier in 1.0 it has HDFS and MapReduce, but then in Hadoop 2.0 it started like giving yarn as well. So finally it has three layers. Hadoop has three layers, which is MapReduce for computation, yarn for resource management, and HDFS for the storage. So we can say storage layer, resource management layer, computation layer. Okay, three layers now Hadoop is providing. So and keeping aside, okay, this is the history of Hadoop, like why we started using the Hadoop. Then Spark came in around 2010, but it became more popular from 2014 around. Okay, so in Hadoop, the two layers like HDFS and the yarn are still popular. Okay, most of the companies they are still using HDFS for storage and yarn for the resource management. And but this MapReduce is there, right? So this Spark started replacing the MapReduce, the computation layer. Why? Because so Apache Spark is 100 times faster than MapReduce. Why? That is because Spark uses in-memory computation. Okay, it's a in-memory computation engine. Because when it all started, RAM was so cheaper compared to other storage devices. So Spark started using the RAM for the computation. And always because it's RAM, when you use RAM, the results will be faster, right? So even in your mobile also, you will prefer which one is having the more RAM, because you will get the mobile apps to work with very quicker results when you use in mobile. So similarly, even Spark uses such kind of RAM for the in-memory computation. So it was, of course, it is very faster than MR. And whereas this Mapreduce, right, it uses HDFS for the intermediate storage. For example, if you are sending a query for summing up some 3 digits, okay, or something like that, so first 2 digits it will compute and it will send the result back to the it will store the intermediate result in HDFS. Then again it will go back to programming, it will compute, and again the intermediate results or computations will be stored in the HDFS. Because of this disk to this one, right, the what to say, calls, because of that calls, Mapreduce was taking a lot of time when compared to Spark. But whereas Spark uses in-memory computation, right, that's why Spark is 100 times faster than Mapreduce. And coming back to the second one, language independent. So MR, which is Mapreduce, right, this is written in either Java and I think in Python also, I feel, but earlier it was only in Java. But Spark can be written in Java, Scala, Python, or in any of these languages we can write the code, okay. And it supports, Spark supports writing code. It can understand the code. If you write it in Java, Scala, Python and R languages, it will accept. And also Spark is implemented in Scala. Most of the people use Scala for faster results when you are working with Spark, okay. And for the people who has SQL background, right, they can also use Spark SQL by using the SQL query. So it became like very easier to use. So people, because of the language independence in Spark, people started using Spark over Mapreduce. And also, see, if you know the concept of Hadoop, right, so it multiple computers will be together, will be connected together to frame a cluster, and we start using that. So when you say HDFS, it's a storage, right? So instead of storing all the data in a single server, we will store it in the multiple server in the form of blocks in HDFS. So again, blocks means where you are going to store in the main disk, so hard disk, so which is another overhead memory for each computer. And when the analyzers, whoever this market analysis people, right, when they verified it in the, let's say there is a 100 node cluster, then they identified that in this 100 node cluster, Hadoop is very good, it is very well, and anyway it uses commodity hardware, it is very well to use. But they noticed that all the storage that is being used is that is stored in the hard disk. But if you see the CPU, every machine will have the CPU, right? The CPU utilization is low. CPU utilization is low in Hadoop. But if you see, CPU utilization should be more for the faster results, right? So that's when they started thinking out of box, and that's when they started using Spark, okay. And next one is cloud adoption increased. That means that pay as you go kind of functionality has come in. So but we cannot shut down the cluster or destroy the resources when we are not using for any particular day. Let's say today is a holiday, I don't want, so such kind of things we cannot do, because we need the data or we need the processing to be done always. So for such kind of issues, they thought, who these market people, right, they thought like we need a solution which will have separate storage and computation layers. We don't want like Hadoop, it has both, right, so storage and the computation layer together. So we don't want such kind of functionality. And anyway for MR it uses storage only Hadoop, right, it uses Hadoop only for storage. And but for computations, maybe for this one storage, they might use Hadoop or Amazon S3, Blob, Mesos, Google, etc. But for computation, now everyone started using Spark. That is because it can run in standalone mode, okay, without any cluster manager. It has its own cluster manager, so it can be run in standalone mode. And it can also use, like it can be built on top of Yarn, which is again a Hadoop, and also Apache Mesos and Amazon S3 kind of. So it has lot of platform independent, right? So that kind of benefit that Spark has over Hadoop, okay. So next one is Spark works well for the smaller data sets. So that like if there are so many smaller data sets, Hadoop will not work, because Hadoop works on a concept called block. So each block will be around 150 MB or something. If it is lesser, then there will be more blocks created in the Hadoop, okay, HDFS, that will cause again small file problem and all that. So in such cases we use Spark, so that it can read multiple smaller data sets and it can perform the computations faster. But whereas Hadoop is cost effective for massive data sets, because it stores the data as blocks, and the computation will be faster because of less blocks will be there for the massive data sets, and it is faster. So these are the main differences between Hadoop versus Spark, or MR versus Spark, okay. So just to summarize, I mean, if someone asks you, we cannot say when it started and all, right, in the interviews. So we can just like maybe these 6 topics you can just explain them. Like if you take the performance, and then due to in-memory computation, Spark is faster, so it's in better performance over MR. You can say like that, okay. These are the parameters you need to explain in the interviews, saying that performance Spark is 100% 100 times faster than MR. And if at all they ask why, then you can explain whatever we just discussed, okay. And the second one is ease of use. Due to language independent, Spark is ease of use, and also Spark has multiple APIs like Spark, SQL, mlib, graphs, streaming and all. Our internal APIs are there, inbuilt APIs are there, so it's very easy to use over MR, okay. And then data processing, so it's again the in-memory computation, okay. Because of the data processing is in memory, Spark is faster, and both MR and Mapreduce and Spark uses the data locality, which is bringing code to the like data. So because of that, the data movement will be less, right? So disk 6 will be less, but still Spark is far better than MR, okay, in the data processing as well. And the cost, again, as I said, both are cost effective on the file types, like the storage, like you can say for smaller data sets Spark is better, and for massive data sets Hadoop is better, okay. And if you come to compatibility, Spark is compatible with Mesos, Yarn, and we can use that in the standalone as well. But for MR we should be using Hadoop cluster, okay. And coming to the fault tolerant, Hadoop uses replication factor for fault tolerance, and Spark uses RDDs for the fault tolerance. So if you just explain about these 6 concepts, that is more than enough, okay. So hope this video is useful to you, friends. Thank you for watching. Please subscribe to my channel for more interesting learnings. Thank you.